This is 8.1 vectors. A vector is a quantity that has both magnitude and direction. The magnitude of your vector is the length of the directed line segment, and the direction of the vector is the angle between the positive x-axis. So for the positive x-axis, I'm talking about over here, and the vector. I want to draw a vector of 60 pounds of force in the direction of 125 degrees to the horizontal. So for these, I just want you to just approximate them. So if I want to do 125 degrees, hold on, if I want to do 125 degrees, then I need to take this angle, start from 0, and go in my clockwise direction to 125. So if I had graph paper, you can kind of figure it out, or if I had a coordinate grid or a unit circle, 135 is about halfway, so 125 is a little bit shorter, so I'm just going to leave this. So that means this angle here is 125 degrees, and then the magnitude of this is 60 pounds. So when I want you to draw the vector, I just want to see that you understand where the angle is, and then just label the magnitude of it. Okay, on number 2 it says draw a vector speed with a speed of 55 miles per hour at a bearing of south 43 degrees east. So if it says bearing and it doesn't have the south and the east on it, normally that would mean you take the vector up here and you go in whatever direction you're supposed to go. However, since I'm doing south 43 degrees east, that means I need to start off in the south direction and veer off into the east direction. So I'm starting off south and I'm veering off 43 degrees in the east direction. So that this angle in here is 43 degrees, and then my magnitude for my vector is 55. Okay. 3, I want to draw a vector with a length of 16 inches at a bearing of 200 degrees. Since there is no north, south, east, west stuff on here, you're going to take our vector and you're going to start off north and you're going to veer off 200 degrees. Well, if I rotate, and you're always going to rotate clockwise for these. So if I keep going, this is 90 degrees, 180. So if I'm at 180 down here, I need to go another 20 to get, so this angle in here should be 20 degrees. This whole thing right here should be my 200 degrees bearing. And then of course, my magnitude is 16 inches. 4, draw a vector with a speed of 8 meters per second at a bearing of north 72 west. So since they give you north, south, east, and west on it, you're going to start wherever it tells you. I'm going to start off north, and I'm going to veer off 72 degrees in the west direction. Well, we know that this is 90, so if I'm going to veer off 72, that may be about here, which means this angle in here has to be 72 degrees. So it's basically 72 degrees between the north and the west. So I'm starting off north, and I'm veering off 72 degrees in the west direction. And on that one, my magnitude is 8 for that. Next, I want to find the vertical and horizontal components for a vector with a resulting force of 52 newtons in the direction of 60 degrees. So first, if it says the word direction, let me come over here. If it says the word direction, basically that means you go from 0 degrees counterclockwise, like you do a normal unit circle. Direction always means from 0 going around. So we're going to move this to about 60 degrees. So that means, oops, let me make that blue again. So that means I want to make this vector length 52, and I want the vertical and horizontal components for it. This angle in here is 60 degrees, so I want the x and the y component form for that. So if we look at our x, this is the adjacent side, and 52 is my hypotenuse. Adjacent and hypotenuse is cosine. So cosine of 60 equals your adjacent over your hypotenuse. So your x ends up being 52 times cosine 60. So you see whenever you find x's, it's going to be equal to whatever the magnitude of your vector is times cosine of your angle. And if I plug in 52 times cosine of 60, that's going to give me 26. Then if we do the y, this is your opposite over your hypotenuse. That will give me sine of 60 equals my opposite, my opposite over my hypotenuse, which gives me 52 times cosine 60 equals y, which basically is my vector times, not cosine, sine. So 52 times, so my vector times sine of my angle is my y. And if I plug 52 times sine of 60 in the calculator, we're going to get 45.03. And those are my vertical and horizontal components. So what we just found on the last screen is any vector can be written as whatever your vector is times cosine of your angle, comma, your vector times whatever sine of your angle is. Where theta is the angle from your positive x-axis. Keep that in mind, it always has to be from the positive x-axis. The magnitude of a vector can be found by Pythagorean theorem. A squared plus b squared equals c squared. And so on the next few examples, even though I've already told you the magnitude on here, after we do the problem, I'm going to prove to you that the magnitude is 500 if we did our math correctly. So I want to draw a vector with a length of 500 in the direction of 132. Or I want to find a vector. So 132, again, I'm going to start here. Okay, I'm going to start with a vector here. Let me do, okay, shape 2, change it to blue. Let's redo this. Let's do this shape. Okay, let's undo all those. Come on. Okay, let's reset. Let's try this over. I need blue because it looks weird when I do the other one. Okay, now let's draw an arrow. Okay, so in the direction of 132 means, this is 0. So if I want to go 132, that means I'm going to be over in this area. That means that I'm going to have 132 degrees here. And then my magnitude is 500. So my vector representation is my magnitude times cosine of my angle, my magnitude times sine of my angle. And if you stick those in the calculator, you're going to get negative 334.57, 371.57. That is my vector. I don't know if I'm going to be able to fit this in here. Negative 334.57, comma 371.57. And then if I want to double check my magnitude, your magnitude equals your square root of negative a, or your x, plus your y or your b. And if you stick all that in the calculator, you will get 500. So you can kind of tell right now, even though I already told you the magnitude, you can tell that we did our math right.